All right, so now we're going to go over E1.4, which is applications of linear equations in one variable. So these are things we should be able to solve without having any kinds of x squares and factoring and quadratic formula and all that mess. So what we're going to look at is when you have these problems, how to analyze them and pick out what's important, and then how to set it up and solve. So at the beginning, I went ahead and put down about 5 steps on how to solve these problems. Excuse me. The first one is to familiarize yourself with a problem situation, okay? Now, depending on what it is, sometimes it's helpful to make a list of everything you know, to make a drawing, to use a chart or a table to help you organize it. So whatever helps you organize the information so that you can analyze it, that's what I suggest you do. I'm a big drawing person, so drawings usually help me. The next thing we want to do is translate it. So now that we have the information and we know what we're solving for, how do we put it into an equation that makes sense? Okay. Then third, we do our mathematical manipulation. In other words, we solve. Okay. And then we check to see if our solution makes sense. Sometimes we can plug it back in to check. Sometimes we just look to see if it is a probable answer, like if it's asking how many miles did this person run? If you get -17, that's probably not a good sign. Okay, so just is it a good answer that could actually be applied to the scenario of the problem? And then number 5 is state the answer clearly using a complete sentence. Now, because we're using software, you usually don't have to enter a complete sentence, but I do want you to be able to think in your mind, okay, I solved for this. What does that mean in terms of this problem? And the reason I want you to take that extra step is because a lot of times it may ask you for something that is not actually what you solved for. You may have to solve for something in order to answer a different part of the problem. So always make sure you check that last step to make sure the answer that you're entering is actually what the problem's asking for and not just an intermediate step that you solved for. Okay, so let's go ahead and look at one. This first one says there are about 232,000 words in the Japanese language. This is 19% more than the number of words in the Russian language. How many words are in the Russian language? Now, in my math lab, it'll tell you how to analyze your answers. I forgot to type that in, so I'm going to go ahead and just write it in as we go. For this one, since we're solving for how many words there are, let's go ahead and just, I'm going to say round to the nearest, what is it? We're talking like thousands. Round to the nearest 1,000. Okay. Because some of these answers come out to, you know, decimals that repeat and whatever. So I'm going to go ahead and just state how we want the answer. So there's all these words in the Japanese language, and all they tell us is that this is 19% more than the number of words in the Russian language. So what I want to go ahead and do is write, well, what do we know about the Russian language? Not a lot, right? All we know is that there's less than the Japanese language. So I'm going to go ahead and state a variable and let that represent the number of words in the Russian language. So I'm going to let x equal the number of words in the Russian language. Okay. So now I want to think about what this is saying. There are 232,000 words in the Japanese language. This is, anytime you see the words this is, that means equals. Anytime you see is, this is, that means this is equal to. This is the same as, okay? This is 19% more than the number of words in the Russian language. So what that's saying is we're taking the Russian language, and it's not the same as it. It's not the same as 19% of it. It's the same as 19% more. Okay, so anytime we deal with percentages, we have to take a percent of something. So we're talking about the Russian language. So we're going to take 19% of the Russian language, that's some value, and then we're going to add that back to the Russian language because it's not only the same as the number of Russian words, but it's 19% more than that. Does that make sense? So I'm going to write that out in words, and then we'll put it into an equation scenario. So, so what we're saying is that the number of Japanese words is equal to 19% more than the number of Russian words. Okay, to find 19% more, we take our original number of Russian words and we add 19% of the Russian words back to the total number of Russian words. Now, we don't have a word for the Russian words, right? Or we don't have a value, so we called it X. So I'm going to go ahead and just put X in here. So what we're saying is we're going to take X and we're going to add 19% of X back to itself. Okay. Anytime we deal with percents, we don't want to leave it as a percent. We want to write it as a decimal so we can do it nicely in our calculator. So 19% is a decimal. I move it 2 places to the left. This would be the same as 0.19x. Okay. So what we're saying is the number of Japanese words is the same as the number of Russian words plus 19% more, right, above and beyond those Russian words. So I'm going to go ahead and put in the number of Japanese words since that was given to us. That was 232,000. And now here's my equation. Now I just have to solve. So remember, anytime you have a plain old x, the coefficient is an implied 1. So 1x plus 0.19x means that I have 232,000 is equal to 1.19x. Just combining these because they're like terms. And then I solve. All I have to do is divide off that coefficient. Okay. When I divide off that coefficient, I end up with x is equal to, excuse me, 232,000 divided by 1.19 is 194957, and then a bunch of decimals, 9831 ... Okay. So remember, x is representing the number of words in the Russian language, and then at the very beginning I said, let's go ahead and just round to the nearest thousandth. So anytime we say round to the nearest thousand, okay, I go to where my thousand is, which is the 4th number here, and then the number behind my 4 is a 9, so that's going to round it up. So that means that we have approximately 195,000 words in the Russian language. Okay. Does that kind of make sense? Okay, anytime we have a percentage increase, we have to take the percent of the original to figure out what that little percentage is, and then add it back onto the original value. So 19% increase in Russian words, we take 19% of the Russian words, and then add that back to how many total Russian words we had, and we're saying that's the same as the number of Japanese words. So that's how we get it set up. Okay, let's look at another one. This one says, in 2011, there were over 146,000 convenience stores in the U.S. The total number of convenience stores in Texas and California was 25,047. There were 3,885 more convenience stores in Texas than in California. Find the number of convenience stores in Texas and California. So what I'm noticing is we're talking a lot about Texas and California. They tell us the total number for the 2 states, and they tell us one state has more than the other state, and then they want us to find how much is in each state. So my first sentence here, that in 2011 there were over 146,000 convenience stores in the U.S., that really doesn't help me in terms of this problem. That's just added info. Okay, so don't get bogged down in the added info. Think about what they want you to solve for, and then pick out what's important. So I'm going to go ahead and write down what I think is important. It says the total number for Texas and California was 25,400. So when we see the word total, that means we're combining them, right? Or we're adding them together. So I'm going to write up here a little plus sign. So that means if I do Texas plus California, the total number of stores should be 25,047. So now I need another way that these two are related, because as it is, I can't just solve for T or solve for C. I don't have enough information. The next sentence says there were 3,885 more convenience stores in Texas than in California. So which one's bigger? Does Texas have more or does California have more? It says there was more in Texas. So Texas is the bigger one. So I'm going to go ahead and write this as Texas is equal to. Always start with the bigger one. How can I write Texas with using a C? Okay, they're not equal. Texas is not equal to C. It's bigger than California. It's bigger than C by 3,885. So that means I would have to add on 3,885 stores to my California stores in order to make those equal. Does that make sense? Texas is the same as California plus that many because it's bigger than California by that many. All right, so now I have two equations and I have two unknowns. The good thing is my second equation is solved for T. So all I'm going to do is plug the second equation into the first, okay? And that's because I have this solved for T. So basically I'm going to take what I know T to be and I'm going to plug that into my first equation for T. So I'm going to rewrite my first equation. T plus C equals 25047. And now I'm going to plug in what I know. I know that T is equal to C plus 3885 plus C is equal to 25047. Now, I don't really need these parentheses. I just wanted to show that I was plugging that in for T. Since there's nothing outside to be multiplied by, I can just drop them. So when I drop these parentheses, I can go ahead and combine my two C's. So I get 2C plus 3885 is equal to 25047. And then I solve by moving my constant to the other side. And then I will divide off the 2. Okay. When I subtract 25047 minus 3885, that leaves me with 21162 is equal to 2C. And then I just divide off that 2. So when I divide off the 2, I end up with C is equal to 10581. Now, once I have an answer, let's figure out what that means in terms of the problem. What were we actually even solving for? So we go back up. We're looking for the number of stores in Texas and California. So if I solve for C, that tells me that California has 10,581 stores. And now I want to see how many Texas stores are there. So once I know California, I should be able to plug that back in. And I'm going to plug it back into my second equation because it's already solved for Texas. So C plus 3885, we know C is 10581. So if I add 3885 to that, that tells me that Texas has 14,466. So I'm going to go ahead and write that over here. 14,466 stores. Okay, makes sense? Maybe? I'm going to look at, there's a couple more. I'll look at one or two more and then I'll have y'all try one. This next one says, Khalid makes an investment at 4% simple interest. At the end of 1 year, the total value of the investment is $1,560. How much was originally invested? Okay. Anytime you see simple interest means we're not plugging it into some kind of like compounded interest or what's the other one? Continually applied interest or investment type thing. Simple interest just means exactly what it sounds like. You're putting money into an account and it's going to apply interest each year, right? So to figure out, without looking at this in specific problem, if you put money into an account, say you have $100, and you put it into this account, and say it gains you a certain percent interest, you would take the interest rate times that $100, and that would tell you how much interest you earned. But if you want to know how much your total investment is now worth, you take that interest that you earned and add it back to your principal amount, or you add it back to your original investment. Okay, and that tells you your overall amount of money. So I'm going to go ahead and write that down just so that we kind of know that relationship, and then we'll plug in what we know from this problem. So what we know is to figure out what your total investment is, you're going to take some money, right, and you're going to apply some interest to it. So I'm going to say interest rate, and we multiply that to figure out what the interest earned is. Okay, and then once we know how much interest we earned, then we add that back to our original amount. How much money did we put in the account? And that tells us how much we earned. That's going to give us our total. Okay, so let's go back to this problem. It says Khalid makes an investment at 4% simple interest. So that's my interest rate. At the end of 1 year, the total value of the investment is $1,560. How much was originally invested? So if we're looking for how much was originally invested, we're solving for money, right? And I'm going to put in quotes money because that's what I labeled it in my little equation here. Okay, how much money did I originally put in? So I'm going to call that X. So this is X, and then I multiply it times my interest rate, which is 4%. I add that back to my original amount, which we're calling X, and it equals my total investment, which we now know is $1,560. Okay, so I'm going to change my percent into a decimal. 4% as a decimal is 0.04 because I moved the decimal 2 places to the left. So, and I'm going to write the number part first. So I'm going to do 0.04x plus x is equal to 1560. And now I can just combine like terms. 0.04x plus 1x gives me 1.04x is equal to 1560. And then I divide off my coefficient, which is 1.04. Which means that x, excuse me, is equal to 1,500. Okay, so remember x was representing our original amount, which in this one it says how much was originally invested. So that means that 1,500 was originally invested. Originally invested. Okay, let's look at one more. This next one is a perimeter problem. It says, the children at Tiny Tots Daycare planted a rectangular vegetable garden with a perimeter of 39 meters. The length is twice the width. Find the dimensions of the garden. So I'm going to go ahead and just draw a picture. Let's draw a picture, and we'll call this, you know, my garden. Garden. Here's my flower. Okay. All right, so here's my garden, and we're talking about perimeter. Remember, perimeter is equal to the total distance all the way around, right? Which we know is 39 meters. So I'm going to put distance around the entire garden. And the way that we get the distance around the entire garden is we add all the sides together. So for perimeter, we do our width plus our width plus our length, right? Because we have a width over here, excuse me, and a width over here, we have a length up here, and we have a length here. Now, the only thing that we're given is that the length is twice the width. So that means I can write the length in terms of the width. So instead of putting L, I could write L as twice the width. Now, if it's twice it, it's double it, right? Or 2 times it. So given that L is the same as 2W, I'm going to go ahead and fill in this equation. My perimeter, my P I know is 39. I don't know W's, so those stay W's. But for each of my L's, since I know that the length is the same as twice the width, I can put 2W in for each of those. And now I have a nice linear equation with only one variable that I can solve for. I'm going to add all my W's together. So I have 1, 2, plus 2 more is 4, plus 2 more is 6. So 6W. And then I divide off that coefficient of a 6, which gives me that W, excuse me, is equal to 6.5. Okay. Now remember, W was our width. So this means that the width of our garden is 6.5 meters. Let's go back and figure out what they asked for. Here they're saying, find the dimensions of the garden. Dimensions is plural, meaning we need both the length and the width. So since our width is 6.5, now all we have to do is plug that back in to find the length. So we know from up here that our length is the same as 2 times the width. So if I do 2 times the width, which we know is 6.5, then that means that our length would have to be an even 13. Okay, so that means our length is 13 meters. So the children's garden is 6.5 meters by 13 meters. Okay. All right, so on the top of page 3, there's one for y'all to try. And then we'll do a couple more. Okay, so on this one, we're looking for the width of a soccer field, and we know that the perimeter is 330 yards, and we know that the width is 35 yards less than the length. Okay, the biggest mistake I see on this problem is people do 35 minus L rather than L minus 35. If it's 35 less than, you always take with the original thing, which in this case is the length, and then subtract the 35. Okay, so again, we can write our perimeter as W plus W plus L, and then I'm going to substitute in for my W's L minus 35, because I know the width is the same as the length minus 35 units. Okay, and then I just solve. I combine all my L's, there's 4 of them. I combine my negative 35s, which gives me the negative 70. Move my 70 to the other side and then divide off my 4, which gives me 100 for L. So I know my length is 100 yards, and then all I have to do is plug that back into the relationship I know about L and W to figure out what W is. Okay, again, W is L minus 35, so I take L minus 35, plug in the 100, so 100 minus 35 gives me 65, which tells me that my width is 65 yards. Okay. Let me look at 2 more problems, and then I'll have y'all try another one. This next one says Delta Airlines fleet includes B737-800s, each with a cruising speed of 531 miles per hour. And I don't know how to say this, Saab 340s, each with a cruising speed of 290 miles per hour. Suppose that a Saab 340 takes off and travels at its cruising speed. 1 hour later, a B737-800 takes off and follows the same route, traveling at its cruising speed. How long will it take the B737-800 to overtake the Saab 340B? So I'm going to draw a picture. Basically, we have this little Saab plane, right? And it's starting here and it's taking off. And it's traveling at its cruising speed of, let's see, what was the 290 miles per hour. Okay. Then 2 hours later, our faster plane, which is our B737, takes off on that same route. Now the only difference here is this one's traveling 531 miles per hour. Excuse me. Okay, and what it's asking is how long will it take the second plane to overtake the first plane? So I want to know, when is that second plane going to catch up to the first one? So I'm going to just make this dotted line. Let's pretend that's the point at which he'll catch up and there'll be he will have overtaken him or caught him. Okay, now at the point where he catches him, at that point, I know that they have gone the same distance. They're on the same route, and once that second plane catches up to the first plane, then they're at the same distance from the start point. So I'm going to say at this point, distances are the same. Okay, so what I need to do is figure out what's a equation for the distance for the Saab plane, and what is a good representation for the distance of the B737. Once I know each of their distances, I can set them equal to solve. Okay, now remember, distance is equal to rate times time. So for the Saab plane, I don't know the distance, but I do know its rate, right? his rate is 290 miles per hour times his time. Now, I don't know his time. I don't know how long he's been flying, so we're just going to call that t. Okay. Now let's do it for the second plane. Distance again is equal to rate times time. We don't know his distance, but we know he's going 531 miles per hour times his time. Now, I can't call it t also because they haven't been traveling the same amount of time. The second plane left later, okay? So notice here it says 1 hour later. So if I call the first plane's time t, he's been traveling longer. The second plane that took off an hour later has been traveling 1 hour less total time than the first plane. So I can call this t minus 1, right? He's been going the same amount of time as the first plane minus 1 hour because he started an hour later. So now that I know the distances for the two planes, now all I have to do is set those distances equal so I can solve. So I'm going to go ahead and say 290t is equal to 531 times t minus 1. I'm going to distribute that, so I get 290t is equal to 531t minus 531, and then I solve by getting all my t's on the same side. So I'm going to subtract 531t from both sides, which leaves me with, excuse me, negative 241t is equal to, these are gone, negative 531. And then the last thing I have to do is divide off that negative 241. Okay, which leaves me with, right over here, t is equal to 2.20339, blah, 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 blah. Okay. So what I'm going to do, since this one didn't come out pretty, let's go ahead and put an instruction up here. Let's go ahead and just say round to the nearest tenth. Okay, tenth is your first decimal place. All right, so what we just solved for is the time. The time is basically 2.2. Now, t is the time of which plane? If I look back at my equations, t is the time for my first plane, my sob plane, right? What my question's asking me for is how long will it take the B737 to overtake it? So I'm not looking for the time of the first plane, I'm looking for the time of the second plane. So I'm going to put over here, we want the B737's time. Okay, which remember was t minus 1. So I know that t is roughly 2.2, so I just plug that in. 2.2 minus 1 gives me 1.2. So basically what that tells me is it's going to take 1.2 hours for the second plane to catch up to the first plane. Okay. All right, let's look at one more. This one says, in a triangle ABC, angle B is twice as large as angle A. Angle C measures 20 degrees more than angle A. Find the measures of the angle. Hint, the sum of the angle measures in a triangle is 180 degrees. So I'm going to draw a picture, and I'm not too concerned with whether or not it's really accurate. Okay, obviously my angles are all going to look the same. So let's call this angle A, angle B, angle C. What they tell me is angle B is twice as large as angle A. So instead of writing a B here, I could represent that one in terms of A. I know it's twice A, so I could write this one as 2A. Angle C measures 20 degrees more than A. More than means I'm adding. So I'm adding 20. Okay, so angle C is 20 more than A. So this is the same as A plus 20, or 20 plus A, doesn't matter which way you write it. Okay, so now I have all the angles labeled in terms of A. I need some way that they are related, or some way I can come up with an equation. Notice my hint here says the sum of the angle measures in a triangle is 180 degrees. What that means is if I add up all the angles, it should equal 180. So I'm going to do A plus B plus C equals 180, And then I'm just going to plug in what I know my relationship with B and A and C and A are. So A stays the same, B is the same as 2A, and C is the same as A plus 20. Okay. Again, there's nothing happening outside of these parentheses, so I can go ahead and drop those. When I drop those parentheses, I combine like terms. I'm looking at my A's. I have 1A plus 2A, which is 3, and then another A, so I have 4A plus 20 equals 180. Then I'm going to subtract 20, which leaves me with 4A is equal to 160, and then I divide off the 4, which means that A is equal to 40. Now, A represents the measure of angle A. So that means that A is 40 degrees, and then all I have to do is plug back into the others to figure out the other ones. B is twice A. So if I do 2 times 40, that gives me 80. So I'm going to say angle B is 80 degrees. And angle C, I take A's angle and I add 20. So if I do 40 plus 20, that gives me 60, which means C is 60 degrees. Okay? All right, there's one for you to do, and I'm going to give you a minute to work on it, and then I'll come back and go over it. Okay? Okay, so on this one, again, we're talking about two well, not airplanes, one an airplane, one's a jet, leaving at different times on the same route and trying to figure out when one will overtake the other. So I have the airplane going 180 kilometers per hour and the jet that leaves 2 hours later going 900 kilometers per hour, and I'm trying to find the point at which they catch one another or where their distances are the same. So I go ahead and write a distance for each one. The airplane, I used 180 t because I don't know the time. For the jet, I use 900 times t minus 2 because its time is 2 less than that of the airplanes. Once I have their two distances, I put it in an equation with those distances equal. I distributed the 900, excuse me, moved my t values to the same side, and then divided off my coefficient, which gives me t equals 2.5. Now remember, t is representing the time of the airplane. What my problem's actually asking me for is how far, okay? How far. It wants to know the distance. How far from the airport will the jet overtake the plane? Now, it doesn't matter which distance I use because at that point, the airplane's distance is equal to the jet's distance. So I'm just going to plug it into the easiest one there is, which was the 180t. So I take my 2.5 and I plug it back in to find distance. So 180t, plug 2.5 in for t, so 180 times 2.5 gives me 450 kilometers, which is the distance that the jet will catch the airplane. That's the distance they've gone from the airport. Okay, so that is the end of E1.4, which is our applications for linear equations in one variable. You can now do that homework assignment in my math lab. If you have any questions, feel free to email me, give me a holler, or definitely use the tools provided in my math lab. All right, good luck.